Hi, this is Penny, and in this lesson we are going to be answering the question, what is light? So what is light anyway? When I ask this question, people usually mumble something about atoms, energy, or they just say, I don't know what it is, but I know we need it to live. So for non-scientists, this is not an easy question to answer. But we are scientists, so we need to know. Maybe an easier place to start is to ask you to think of some examples of light. If you like, feel free to pause the lesson to write down 3 examples of light that you've come across today, then hit play when you're ready to resume. So click pause now. Got your examples? Good. When I ask people to think of examples of light, they usually say a light bulb, fire or flame from a match or a candle, and the most obvious option, the sun. From these examples, we can see 2 general categories of light sources, natural, like our sun, or artificial, such as a light bulb. Natural sources of light are found in nature and can include lightning or light given off or emitted from living things, such as these fireflies. Artificial light, on the other hand, is emitted from man-made sources, such as a flashlight or a light bulb. So now we have some examples of light. But let's get back to our original question. What is light? A clue is in what light enables you to do. It lets you see things. And in simplest terms, light is a form of visible energy or energy that you can see. So how do we know it's energy? A big hint is that it can be transformed into other forms of energy. For example, have you ever noticed that road pavement gets extremely hot on a warm sunny day? But it cools off if clouds shield it from the sun. What this tells us is that the light energy from the sun is being absorbed by the pavement, causing it to gain heat, or thermal energy. Another common example are solar cells, and they're able to convert light into electricity. Plants are able to absorb light energy and convert it to chemical energy that is stored in sugar. Now let's consider the largest source of natural light, the sun. The sun sends out straight rays of light in all directions, kind of like the spokes of a wheel. Scientists use the Latin form of spoke, radius, from which we actually get the scientific term for light, radiant energy. For those of us that live in urban areas, it's pretty clear that we're surrounded by sources of light. Even in a blackout, if the sky is clear, natural sources of light are available from the stars or light being reflected off the moon. Now let's explore both natural and artificial sources of light in more detail. The light sources we are going to cover fall into 2 general categories, incandescent or luminescent. And when we look at luminescent sources, we're going to actually look at 4 specific types: fluorescent, phosphorescent, chemiluminescent, and bioluminescent. Some objects emit visible light when heated, such as this light bulb. Electricity heats the metal wire or filament in the center of the bulb, and it becomes so hot it glows and emits light. We call this incandescence, which literally means to become warm, glow, or kindle from within. Other examples of incandescence include a hot stove element or the molten lava ejected from a volcano. Now, the key to identifying this type of light source is heat, and lots of it. If you touch an incandescent light source, you will likely get burned. There are a couple of energy transformations that take place in order to produce the light we see. In the case of our light bulb, electrical energy is transmitted along the wire and is converted to thermal energy, which is then converted to visible light energy. Remember, when you think of incandescence, think of a candle or another hot object that emits light. Now let's talk luminescence. This is light given off in the absence of heat. Sometimes we call this cold light. Our first example is fluorescence. Many substances will react in the presence of UV light, which is similar to our visible light in that it is also energy, however, it is usually invisible to us, meaning we can't see it. When UV light strikes a fluorescent object, the object will immediately glow or fluoresce, like our friend the scorpion. The scorpion is now emitting visible light. There are many substances that fluoresce when exposed to UV light. Take the mineral aragonite, for example. In daylight, the mineral looks just like a white crystal. But expose that same crystal to UV light, and you instantly get a beautiful, bright pink glow. Turn the UV light source off, and you immediately go back to the white crystal. The energy transformation required for fluorescence to occur can be summarized as UV light energy goes in, the energy is absorbed by the particles in the object or organism, and then visible light is emitted. Now let's talk about phosphorescent light sources. Here is a phosphorescent statue of a bird. Right away, you've probably noticed that this looks remarkably similar to the scorpion that we just looked at in fluorescence. And it is, in that the material absorbs UV light and emits it as visible light. In fact, looking at this picture, you wouldn't be able to tell if it was fluorescent or phosphorescent. So how can we tell the difference? Here we have two dishes containing two different pigments under natural light. One is fluorescent and one is phosphorescent. Let's turn out the regular overhead lights and turn on a UV light. Now both dishes are glowing, but we still can't tell which is which. So let's go one step further and turn off the UV light as well. Bam! Notice the dish on the left is almost invisible, whereas the dish on the right is still emitting light. This highlights the major difference between these two types of light sources. Fluorescent sources emit light immediately. If you stop the energy source, they stop emitting light. Phosphorescent sources emit light slowly and continue to do so even after the UV source is removed. Cool, right? The third and fourth types of light sources we are going to look at are generated by chemical reactions. If the reaction does not take place in a living organism, we call this chemiluminescence. Let's watch an example of someone lighting a glow stick. By breaking the interior of the stick, chemicals mix, react, and produce light. The energy transformation for chemiluminescence is very simple. Chemical energy is converted directly into visible light energy. If chemiluminescence takes place inside a living organism, we actually modify the name and now call it bioluminescence. Bio means life. My favorite example of bioluminescence has to be jellyfish. These organisms, like so many other deep-sea creatures, have to create their own light because only a small amount of sunlight can reach so far beneath the ocean's surface. Bioluminescence has other purposes as well. It is excellent for finding or attracting prey. Glowworms in the caves of New Zealand use bioluminescence to attract insects, which then get stuck in a sticky thread that they secrete. On a more romantic note, fireflies actually flash light so that males and females can communicate and select mates. So sweet. So here's how to tell which type of light an object is emitting. First question, is the object producing heat? If yes, then it's incandescent. If no, then it's a form of luminescence. Next question, is the object excited by light? If yes, then we have to ask, is it immediate? If it's yes again, then the object is fluorescent. If no, then the object is phosphorescent. If the object is not excited by light, then we ask, is it produced by a living organism? If yes, then the organism is bioluminescent. If no, then the object is chemiluminescent. I hope you now have a better understanding of light and its sources. So here's the big picture in regards to the question, what is light? Light is radiant energy. It can be natural or artificial. And sources of light fall into two major categories, incandescent, which are heat producing, or luminescent, no heat or cold light. The types of luminescence that we have explored are fluorescent, phosphorescent, chemiluminescent, or bioluminescent sources. Thank you for watching.